Hey, Neil Smith here with U.S. Captain's Training. We are looking at the solution to practice problem 8 in our Amplitude problem set. This is a great problem to go off and try on your own right off the bat with no references. It's straightforward and there's not really any tricky parts as relative to the other problems. So just charge right ahead and give this one a try. Good luck and let's get started.
Here we go. We're going to calculate the deviation based on the amplitude of the sun, and this is practice problem 8. Let's jot that down. Problem 8. And in each of these problems, we are given information. So let's write down these pieces of given information. The first one is the date. It's May 11th. The date is May 11th. And it gives us a zone time. We're going to calculate that, but the position is latitude and longitude. So we're going to get a DR position, which is equal to latitude 17 degrees, 30 minutes north, latitude 17 degrees, 30 minutes north, and longitude 63 degrees, 55 minutes west. 63 degrees, 55 minutes west. Take your time recording these because if you're going to use them during the problem, they need to be right. When an amplitude of the sun's center is observed on the celestial horizon bearing 301 per standard magnetic compass, so sun bearing is equal to 301 PSC, 301 degrees PSC. Variation for the area is 10.5 west. Variation equals to 10.5 degrees west. Chronometer reads 10:37:10. So the chron time is equal to 10:37:10. 10 hours, 37 minutes, and 10 seconds. Then it gives us a chron error, which is equal to 2 minutes, 8 seconds slow. 2 minutes, 8 seconds, and it's slow, so we add it to catch back up. And what is the deviation of the compass is what the problem is asking. So deviation, that's what we're going to calculate. What is the deviation? First thing we do is calculate the Greenwich Mean Time, GMT. GMT, that's what we have to find. We take the chron time, 10:37:10 of 10:37:10 hours, minutes, seconds, and then we account for the error to 0208, right? 0208, 0208, and then it's slow, so we add it. We're going to add that. So 10 plus 8 is 18 seconds. 7 and 2 is 9. 3 and 0 is 3 minutes. 10 hours, 39 minutes, 18 seconds. The chronometer is based on 12 hours, like an analog clock. So it can go around twice. So there's ambiguity in this thing. So what we need to do is add 12 hours to it, which comes to 22 hours, 39 minutes, 18 seconds. We need to figure out which one of these we were in. There's a shortcut here because the problem says 1839. Well, let's check it out. Longitude. We take our longitude which is 63 degrees, 55 minutes. We might have to account for that 55 minutes. So 63 degrees west divided by 15. Let's see this. 63 divided by 15 equals 4.2. Good. So we round it. This one we round down to just 4. And that 55 minutes, if we divided 64 by 15, it's not going to change anything. So 4. It's 4 hours. We need to figure out, do we add or subtract this? And we can figure that out on this west. So if we were to draw a little diagram here and put the time zones in it, if we go to the east, we add. If we go to the west, we subtract west. So in this case, we're west, we're going to subtract these 4 hours. If we do that, so we subtract 4 hours from here, subtract 4 hours from here, and try to figure out where we are, like which one of these to use for GMT. 10 minus 4 is 6. 6 hours, 39 minutes, 18 seconds. Or 22 minus 4 is 18. 18 hours, 39 minutes, 18 seconds. Which one of these do we use? Well, this is the AM, right? 6 a.m. And this one's the PM, right? This is more like 6 p.m. So where are we? The sun was bearing 3:01 PSC when we saw it. That means it was in the west. That means the sun was setting. So we were in the PM. Which one of these are PM? Here we are in the PM at 1839. So here is our GMT. And when we subtracted the 4 hours, we subtracted the 4 hours, we were 18. Good, which lines up with the zone time given in the problem right there, 1839. So this is our GMT, and we subtracted, we're still in the same day. So GMT, and this is same day. So we're GMT is equal to 22:39:18. 22:39:18 hours, minutes, seconds, and it happened May 11th. Now that we have this, we can figure out, we can jump in the Nautical Almanac, we can figure out our declination, our D value, whether our D value is increasing or decreasing. So let's do that. So we're May 11th, 22 hours. That's the information we need first. May 11th, April, May 11th. So here we are, May 11th, 22 hours. 10, 11, we cruise down the minutes to 22. And now we're north 1802.1. And is it getting bigger or smaller as we go down? Bigger. So north 1822.1 getting bigger. North 1822.1 getting bigger. Degrees, minutes. I'm going to double check that because we messed this up. It's all for not 22. So the 11th, 22, north 1802.1. Good thing we checked it. That would have thrown us off. We could have the wrong answer. 02.1. Okay, and now the D value is down here, the bottom. D is 0.6. 0.6. And that's the value. Now let's get the D correction. And so we'll go to increments 39 minutes. The increments, the 39 minutes. There we are. We're going to be over here. So here's the D value, and then the correction or 0.6 is, that's our value. Here's the correction applied, 0.4. 0.4, and we're adding it. 0.4 minutes, and we're adding it. So we end up with north 1802.5 minutes. We need to get all these into degrees. So what we're going to do is divide by 60, and we're going to end up that our declination equals north 18 point, whatever this comes out to. 2.5 divided by 60 equals 0.04. North 1804 degrees. This is the declination we're going to use. And now we're going to get our latitude. So our latitude was given to us up here. Latitude 17 degrees, 30 minutes north. So we need to get this 30. We need to get all this into degrees. 30 divided by 60. So we're going to have latitude equals 17 point, whatever this is, 30 divided by 60.5. And now this is in degrees, and this is north. Good. So with these numbers, we can put them into our formula. Up here, we're going to say sine amplitude equals sine declination divided by the cosine of latitude. So we'll set this up and say the sine of our declination is 18.04, sine 18.04 over cosine of 17.5, and this is equal to, let's punch these in, sine 18.04 equals 0.30968. 0.30968. I would double check your numbers here because there's a lot of them. We go out to 5 decimal points places. 30968. And we round that last one based on the next digit. We're looking good. It's cosine 17.5. Clear. Cosine 17.5 equals 0.95372. 0.95372. Double check. 95372. Good. And we'll do this division here. 0.30968. 30968 divided by 0.95372. 0.95372 equals 0.32471. 0.32471. And what this is now is the sine amplitude. Whoa, that's a sharp pencil. Sine amplitude. So equals this. So what we do is we take amplitude equals inverse sine of 0.32471. This is going to give us our amplitude in quadrantal notation. It's going to be in a quadrant of the compass. So, second, inverse sine, 0.32471. 32471 equals 18.9. 18.95. We're just going to take it out to 1 decimal point. 18.9. 18.9. We need to name this. It's either east or west based on whether the bearing of the sun we saw was west, so is setting. We're going to name it west. And it's going to be north or south based on declination, which here is north. So what we get now, we need to figure out amplitude from north to get it in degrees true. So if we create our little compass here, north, south, east, west, we say we were west this way, and we were north of that by 18.9 degrees. So this is us in this quadrant. We need all 270 of these degrees plus these 18.9. So now our amplitude from north is going to be 270 plus 18.9. 270 degrees plus 18.9 degrees. This is going to equal 270 plus 18.9 equals 288.9 equals 288.9 degrees true. Let's throw it in to our compass correction here. T, V, M, D, C. When we go down, we add west. So 288.9 degrees true. Variation was given in the problem is 10.5. 10.5 degrees west. When we're going down, we add it. So 288.9 plus 10.5 degrees west equals 299.4. 299.4 degrees magnetic. And now deviation is what we're calculating. Compass was given in the problem 301 PSC. 301.0 degrees PSC. Now we take that 2994 minus 301 equals 1.6. 1.6 is the difference. We got to figure out, is that east or west? 299 to 301, we added. So when we go down, we add, it's west. 1.6 degrees west deviation is what we calculated. Let's check it out. Here's the closest one. So they're all west, but by far, it's not this one. These are too far off. 1.5 west was the closest answer to ours, which was 1.6. So we came up with the right answer to practice problem 8.